review real quick in 7th grade, we did Pythagorean theorem, right? And when we did Pythagorean theorem, we did a squared plus b squared equals c squared and all that. And let's say we did all of the math and we got a squared equals 25. How would we figure out the value of just a? What do? We take the square root, right? The square root is the inverse of a square. So a is equal to 5. I want you to keep that in mind. So we're going to make a little star. Square root is inverse of squared. Okay? I need you to keep that in mind as we go through today. You do need to have your calculator handy because all of the things we do today are going to be super visible on our calculator, right? We're going to connect them back. All right, so we're going to look today at, this is talking about when he's building a square deck around the hot tub. How large should the deck be? He needs to determine the side lengths of the different sides of the deck for the possible area. So remember, when you square something, you're getting the area. If you take that square root, you're getting the side length, just like we did in Pythagorean theorem. Okay? So we have a bunch of different equations here. So if the area of the deck is 49, how do we find the side length? Yeah. We're going to take the square root, right? And what we do on one side, we do the other. So we get x equals what? All right, 7. Now, for the purposes of the deck, 7 is going to be the only valid answer. What if I took away the context of the deck and I gave you just this equation? Would 7 be the only possible answer? If I just said it's just a random equation with no situation. I don't know. So what this is saying is 7 times 7 is 49. Is there nothing else times itself that will give you 49? The fact that I'm asking that question should lead you to believe that there is something else. Isaac. Yes, a negative 7 times 7 will also give you a positive 49, right? So we can write x equals 7, x equals negative 7. Or I'm going to have you revisit a symbol that we talked about a while back. We can also write x is equal to plus or minus 7. This is going to be the better way. You're going to see this symbol as we go through and work towards the quadratic formula. When we write plus minus 7, that means, in fact, that we have two solutions, 7 and negative 7. Okay? So let's try B. How are we going to solve B? X equals plus or minus 10, right? Because we're taking the square root of both sides. Pretty easy so far? Okay, what about C? Are we still taking the square root on both sides? Is there a nice number for the square root of 15? No, so we're just going to write this. We're going to write x is equal to plus or minus the square root of 15. Because that number is either going to be positive or that number is going to be negative. Okay? If we wanted to get that really ugly value, we could put it in the calculator, but let's not. Because while you think this is ugly, the decimal's even uglier. All right, now we have a couple more things going on D. What do you think we should do on D? Nate? Yeah, let's get that x squared by itself. So we can divide everything by 2. We get x squared equals 9. And now what? We take the square root. We get plus or minus 3. Very nice. All right. What about E? How would we solve this? We're going to add 4 on both sides. and then we're going to take the square root, and x is equal to plus or minus 2. I promise there's a purpose. Let's think about this next one. Be careful. We would what? Minus the 2. X squared equals negative 2. I'm going to take my square root. What did you say, Luke? There, it is no solution. Is there a number that you can multiply by itself and get a negative number? No. So there is no solution here because the whole purpose of squaring a number is it has to be identical, right? You're multiplying it by itself. We're going to look at E, F, and G in the calculator in a minute. G, what do I need to do? We're going to minus 3. X squared equals 0. What's the square root of 0? Okay. There is no plus or minus 0 because 0 is just 0. All right. So I want to make some connections for you. I want to make a couple of connections. I need you to go to your calculator here. And we're going to go to a graph. And we're going to plug in. Now notice this says equals 0. Normally when it's a quadratic, it's equal to y. So we're going to pretend that this 0 is a y. And we're going to put in x squared minus 4. What do you notice about this graph? It is a parabola, and we know that because it's squared, so that's good. Anything else? The zeros are negative 2 and 2. So when we did all of this square root method, we are actually calculating the zeros, the x-intercepts, the solutions, the roots, without the calculator. Okay? So we are actually finding those pieces. And let's think about why that is. This is usually set equal to y. If I go back up here, this is y equals. Well, what am I putting in place of y? I'm putting 0. And when y is 0, we get our x-intercept. Do you see that? All right, let's try another one. Hit tab. Let's put in f. Let's put in f. We're say x squared plus 2. What happened here? Okay, it did shift up 6, but there's no solution. It doesn't touch the x-axis, which is why we have no solution here. This one, we can move our 3 over. We get 0. I mean, we can graph that. We know x squared. We can put plus 0 if we want, but you can see there's only the one solution. Okay? We're going to come back to that in just a minute. We don't need to answer all of these questions. We're okay here. Let's turn the page. Here it talks about to solve a quadratic we have in the form of ax squared plus c equals 0. Isolate the x squared term and take the square root of both sides. So essentially this is saying what we just did, right? Get everything away from the x squared and then take your square root. So what I would like you to do is come down here to the try these, A, B, C. Notice over here, plus or minus symbol is red, plus or minus, and that means we have a positive answer and a negative answer. So I would like you with your table to try to find the roots using the square root method of A, B, and C. All right, so take a moment. So when we look at these, things I want you to keep in mind, if we were to graph these, so for example, letter A, if I moved my 1 over, I would get x squared minus 11 equals 0. When I go to my calculator, let me move that so we can see the whole thing. And I do x squared minus 11. Notice that these roots are very ugly. Okay, we've talked about those in the past. You can do 6, 1 to get those roots. Ooh, that's a very ugly number. And we came up with this square root. So if we wanted to see if those matched, we can go to calculator and we can do the square root of 11. And notice we get 3.16, which is essentially 3.316, excuse me. So we have 3.32 and a negative because we have a positive of that and a negative. So do you see how those relate? All right, let's look down here at this table. When you have a positive number equal to our x squared, we're going to have two solutions. So an example of that might be, like we did on B, x squared equals 4, right? We had two solutions. If we have it equal to 0, we're only going to have one solution. So on the example we did on the front, right, x squared plus 3 equals 3. When we move this over, we got 0. And then the example we got on the front where we got a negative number, x squared minus 3, we'll just make one up, equals negative 3, I'm sorry, positive 3, right? Oh, no, wait, that's a positive number. Which one was it before?
0.
No, it was positive 3 and positive 3. Sorry. There we go. Then we would get, no, that was the 0 one. 2. Got it. It's been, I need some coffee. There we go. So if you need a negative number answer, you're going to get no solutions because that was the one we graphed where it was above the x-axis. That was like this. This one is exactly on the origin, and this one is going to be down here. Okay? So let's look at some real-world application for this. Now, remember, when you do real-world application, are you going to have a positive and a negative number? No. It says a square frame has a 2-inch border along two sides. The total area is 66. Answer the questions. Help you write. Okay, label the sides of the unshaded squared X and fill in the boxes. So what is the area in terms of X? Let's think about that. What is this side length? X plus 2, and how many of them do we have? 2 of them. So this is X plus 2 quantity squared is equal, what was our area in square inches of the whole thing? 66. So we can solve equations like this by isolating our variable, and that's what we're going to look at in this next piece. So if you look at example B, they've taken our equation. I want to talk you through what they did. They went ahead and they took the square root of both sides. So instead of moving our constant like we did before, the constant is stuck in the parentheses. So we're going to have to take the square root on both sides to get that square to cancel out. So do you see what happened on these steps? And remember, when you take the square root, it's going to be plus or minus. This does not simplify because 66, when you simplify it, is 2 times 3 times 11. Then you can move over your constant. Now, you cannot put a constant with a radical. So we just end up with negative 2 plus or minus square root of 66. And that actually means that we have two different equations. We have negative 2 plus the square root of 66 and negative 2 minus the square root of 66. All right, so that's what I want to look at with you today. It does go on. It went ahead, it put this in the calculator, and we got both of these answers. Do you want me to show you how to put that in the calculator, or you feel like you can do that? You just put these in. Now, do both of these solutions make sense in the context of our frame? Remember, this all had to do with this picture frame up here. Do both of these answers, meaning the side length is a negative 10.12 or the side length is a positive 6.12, do both of these make sense? No, which one makes sense? Only this one makes sense, right? We cannot have negative side lengths. It just doesn't make sense in real life, right? All right. So let's look at this and see what we can do. I'm going to do A with you. Actually, I'm going to do A, B, and C, and then we'll go from there. So again, before the squared was on the X and we just moved our -5. We can't do that. It's in the parentheses. It's the whole quantity. How do you undo a quantity squared? You take the square root. And if I take the square root on the left, I have to take it on the right. So now I have, that makes my parentheses go away. I have X minus 5 equals plus or minus 11. Remember, when we take a square root, it is a plus or a minus. We do not have a context to go with this, so we have to use the both positive and negative. This means that we have two different equations. We have X minus 5 equals positive 11, and we have X minus 5 equals negative 11. Do you see that? How do we solve, actually both of them, we solve them the same way even though we get this different answers. How do we move this -5? We're going to add 5. So if I add 5 to 11, what do I get? 16. What do I get when I add 5 to negative 11? Negative 6. If I moved my 121 over, these would be my roots. Okay? Would you like to see that in the calculator? Or does that make sense? Okay. So let's try this one. Or do you want to try this one? You try that one at your table. When you take the square root, this one's not quite as pretty. We cannot take the square root of 6. We do need to move our 1 over. Can we put a 1 with a radical? We put it in front. 1 plus or minus the square root of 6. And then what do we do with the 2x? We divide it. So we get x equals 1 plus or minus the square root of 6 all over 2. And then you're finished. You could put that in the calculator and you could get your decimal, but it's kind of ugly. All right? That is very much ugly, but when we get further down this week into the quadratic formula, it's going to make more sense. All right, this last one. We're not going to move this 36 over. I know that's what you want to do, but can we factor this? Remember when we did that way back when? Nope. It is a perfect square trinomial, right? What are we going to get? What kind of 6? X, sine of b, x minus 6 quantity squared equals 2. Do you see how we did that? If you don't remember how to do that, you can do AB or AC, and here's B to get your factors. So we take the square root of both sides. X minus 6 equals plus or minus the square root of 2. We add 6. Can I put 6 with a square root of 2? No. 6 plus or minus the square root of 2. Okay? How do we feel about square root method? Not too bad. All right, here's what I'm going to ask you to do for practice. Turn that page. All right, I need you to do 6, 7, 8, 12, 14, 13, 15. So 12 to 15. And then I would like you to try number 16. Okay? You have to try it. If you get it wrong, it's not going to hurt you, but I want you to try it. So this is due tomorrow, all right?